Yo, what's up everyone? Today we're going to be doing the States of Matter section of the 2020 USNCO local exam. So this is going to be from question 13 to 18. So let's get started with question 13. Which gas has an effusion rate closest to half that of oxygen at a given temperature? This is going to deal with Graham's law of effusion. Graham's law of effusion says that the rate of effusion of one gas over the rate of effusion of another gas is going to equal the square root of the molar mass of the second gas over the molar mass of the first gas. So if we say that the first gas is oxygen, let's say R1 and M1 are oxygen, R1 over R2 is going to be 2, and M1 is going to be 32 grams. R1 over R2 comes out to 2 because if R1 is 1, we know that R2 has to be half that, so 1 half. So R1 over R2 is equal to 2. M1 has to be 32 grams because oxygen is diatomic, so oxygen is always in its O2 form. And so all we have left is M2. If we solve for M2, that's the molar mass of our mystery gas, and we can just match that up to the answer choices. So from here is just a bit of math. If we square both sides, it's 4 equals to M2 over 32 grams. So M2 is going to equal 128 grams. Out of all our answer choices, xenon comes the closest to this number that we got, 128. Xenon has a molar mass of about 131. So D xenon is our answer. Let's go to question 14. Which compound has the highest normal boiling point? We have 1 butanol, 2 butanol, 2 methyl, 1 propanol, 2 methyl, 2 propanol. And so these all just contain the same atoms, just listed in different ways. So based on their orientation, that's going to affect their boiling point. Another thing that we can't look at is going to be the fact that all of these can undergo hydrogen bonding. So all we're really working with here is going to be the shape that these molecules form. If you draw out all of these molecules, you'll realize that a lot of these B, C, and D are really like they bend in towards themselves. A, on the other hand, is a long straight chain. The fact that it's a long straight chain means that there is greater surface area, therefore a greater likelihood of polarizability, therefore greater, stronger London dispersion forces. So therefore A is going to have the highest intermolecular forces, therefore it's going to have the highest normal boiling point. So that's question 14. The answer is A. Let's go to question 15. A portion of the phase diagram of elemental sulfur is shown below. What statement about sulfur is correct? Alright, let's go through all these answer choices. A. Rhombic sulfur cannot be sublimed without first converting to monoclinic sulfur. So sublime means to go from the solid state all the way to the gas state right away. And so you can go from the solid state or the rhombic state down to the gas state over here without passing through the monoclinic state. So A is not true. Let's look at B. The conversion of rhombic sulfur to monoclinic sulfur is exothermic. The conversion of rhombic sulfur to monoclinic sulfur is from here to here. The conversion is going to require an increase in temperature. To remain at the same pressure, you must increase your temperature. A reaction requiring increased temperature is indicative that you're dealing with an endothermic reaction, not an exothermic reaction. So B is also not correct. C. Rhombic sulfur is denser than monoclinic sulfur. This makes sense. Rhombic sulfur to monoclinic sulfur, if you go from rhombic sulfur to monoclinic sulfur, you'll realize that the pressure increases. If you have higher pressure, the molecules are more tightly packed, therefore the rhombic phase is more dense than the monoclinic phase. So C does make sense. Let's just make sure that D is wrong. So C could be right. Let's look at D. At atmospheric pressure, monoclinic sulfur cannot be in equilibrium with liquid sulfur. So at atmospheric pressure, which is right here, monoclinic sulfur can be in equilibrium with the liquid form, right here. So D is not correct, and therefore C is the right answer. That's 15. The answer is C. Let's go to question 16. In which are the ionic compounds listed in order of increasing magnitude of their lattice energy? All of these are ionic compounds, which means that they're going to be their attraction is going to be purely Coulombic. So we have four molecules that we're dealing with here. We have CaO, we have RBI, we have LiF, and we have LiI. Their force of attraction is going to be based on the charges of these molecules. So, for example, if you have calcium and oxygen, calcium has a charge of +2, oxygen has a charge of -2. We know that the force of attraction is equal to K Q1 Q2 over R squared. Now, K and R squared we're not really going to know, so we're really going to be dealing with this Q1 Q2 value. Q1 Q2 value. The more we can maximize this value, the stronger their intermolecular forces are. So Q1 Q2 in this case is going to be +2 times -2, which is -4. If you look at RBI, LiF, LiI, all of these compounds are going to be +1 and -1 cations and anions. So fluoride is a -1 ion, lithium is a +1 ion, and this goes for all three of these compounds. So all of their Q1, Q2 values, are going to come out to +1 times -1, which is -1. So what this means is that we know that calcium oxide is going to be the strongest out of all four of these. And therefore, we have to look at which answer choice shows that calcium oxide it has the greatest magnitude of lattice energy, and that is answer choice D. That's the only answer choice with calcium oxide as the greatest magnitude. So that's 16. Let's look at 17. Sodium halides crystallize in the rock salt structure, which has a cubic unit cell with 4 formula units per unit cell. A sodium halide has a density of 2.83 grams per centimeter cubed with an edge length of 462 picometers. What compound is it? All right, so there's a lot here. Let's start by establishing the cubic unit cell. So we have some sort of unit cell. It's the rock salt structure, which you don't really need to know. We just know that there are 4 atoms in here. 4 atoms of our sodium halide, whatever that is. And 4 atoms of those is going to occupy 462 picometers, a cube with a side length of 462 picometers. Now with our density conversion, we can actually take this and convert 4 atoms to the mass of those 4 atoms. So let's see how we're going to do this. We have 462 picometers as our edge length. That is 462 times 10 to the minus 10th meters. And so in order to turn this into volume, remember the volume of a cube is just side length cubed. So we take this value, 462 times 10 to the minus 10th, this should say centimeters, and we cube this, and this is going to give us 9.86 times 10 to the minus 23rd centimeters cubed. Now this is important because with this, we can turn the volume into mass. If we take this value and we multiply it by 2.83 grams per centimeter cubed, you'll get the mass of 4 of these atoms. And the mass of 4 of these atoms comes out to 2.79 times 10 to the negative 22 grams. All right, what can you do with this information? Well, what we just found out is that 4 atoms is going to weigh 2.79 times 10 to the minus 22 grams. We want to find out the molar mass. The molar mass is what really helps us. With the molar mass, we can just look at the molar mass of our options, of our answer choices, and just match that up. So if we just keep this proportion, but adjust to find the molar weight, by, instead of having 4 atoms, we have 6.02 times 10 to the 23rd atoms. If you have a mole of atoms, let's see how much a mole of those atoms weigh. Let's just set this to x. And if you do out your proportion, x is going to come out to 42 grams. This means that the molar mass of your sodium halide is going to be 42 grams. And the only answer choice with a molar mass of 42 grams is sodium fluoride, which is answer choice A. Let's go to question 18. The tetragonal or something unit cell of white tin is shown below. Each circle represents a tin atom with the gray circle sitting on the 4 vertical faces of the unit cell. How many tin atoms are contained in this unit cell? Alright, so let's start by counting the shaded ones. So the shaded ones are going to be face, so they each represent 1/2 of an actual atom. You have 4 of them. They each represent 1/2, so that's 2 from there. You have 8 of these corner atoms, and they all represent 1/8 each, so that's 1. And you have 1 of this blank one just chilling in the center, so that's 1 on its own. And if you add all of these up, that's 4. So the total amount of tin atoms that are contained in this unit cell is 4, which is answer choice B. And that's the entire section. I hope this was helpful, and I hope to see you later. Thank you.